Okay, we have a Kenwood TS-430S on the bench. It's a radio that I've owned for a few years, probably more than 10. It's had a few owners. History is not entirely known. I'm aware that the last owner did have it stored in a shed. So given that, it's not appearance-wise in terribly bad condition. It has developed a few issues in the last few years, making it almost useless. And so I'll just demonstrate by switching it on. And so it's evident there's this tone interfering with the receiver. Not entirely sure where that's coming from, a bit interesting. It does reside after a while, but it's always there. I think it's affecting the sensitivity. Also, we'll just turn that down. Also, there's general receiver desensitivity on a number of the bands, and that's a fairly known fault. Generally, it's oxidized filter relays, having a lot of additional resistance or impedance. So what we're going to do is open the radio up, see if there's any visible signs, work out a little bit of a strategy of how we're going to deal with it. So this is the receiver issues. This radio does also have some transmit issues, that the transmit fluctuates in power from time to time. It's a very intermittent fault, and probably a bit hard to pin down, so we're going to try and look at that as well. It's likely to be a dry joint or similar, or a connector. So we're just going to probe around and see if we can sort the power issue out. That may not be an overly serious one, except if the dry joint's on the main power amp. A little bit of rebedding of components. So anyway, we're going to open the radio up. So quite a good radio in terms of access. There's the top and bottom panel, they come off fairly easily, and I haven't probed around much in this radio, so a little bit's an unknown, but from what I can see, it does actually look like a fairly well laid out radio. And, yep, there we go. Okay, we'll just unplug the speaker so we don't rip that off. So I'm taking both covers off because this is going to be a general exploration of the radio, just to see what we can see. So we're looking at the bottom of the radio now. This is the bottom cover removed, and the circuit boards look very clean. I'm happily surprised to see that they look like they're in fairly good condition, and maybe have something to do with being on the bottom, that the dust doesn't collect there easily, but nonetheless I'm happy to see that. Okay, well, we're now looking at the top of the radio, and a little bit of dust, but also pleasantly surprised to see that it's not in terribly bad condition. A little bit of metal wear along there, but there's no rust, and very little dust, so that's all a positive sign. Okay, we've got the speaker plugged in so we can hear what the radio does when we switch it on, and we've got that annoying tone again. So this is in the top of the radio. Just having a bit of a look around. The relays in question for the filters, which are also definitely part of the problem, in the back here, and that's the power amp here. So we've got to remove that to gain access to them. And I think what I'll be able to do is to remove the covers, and we'll clean the contacts. Okay, you'll notice that the tone has largely resided, but it's still there, and it would be desensing the receiver. There's a little bit of variation. Just it's interesting. To see what that is, that is quite hot. That's very hot. Let's have a look at the schematic and just investigate, find out what that actually is, but that's very warm. Okay, before we remove anything, just by way of explanation, this is the schematic of the IF board. So that's this board here. So we've got the filters, that's these guys here, and we've got all the filters installed except for one of them. Over here is IC9. IC9 is this regulator here, is a 5-volt regulator, and it's getting very warm. It's almost too warm to touch. So not entirely sure what the cause of that is, but it may actually be leaking caps. So we're going to replace the electrolytic capacitors related to IC9. This plug is this one. Not sure if that's clear. There it is, this one here, and that traces all the way around, comes up here, and so that's the display board. So we'll just switch that on again. So if we take this, there we see there's definitely that's the area where it's being generated from. So it's like it's coming from the display. Okay, this is the display board. Fairly straightforward circuit. Interestingly, there's a DC inverter. So we've got the 5 volts coming in here, 2 switching transistors and a transformer, which would be this guy, and a rectifier, and not clear what voltage it's generating, but there is reference to 20 volts over here on this transistor collector. So yeah, obviously a step up to a high voltage for the display, and I gotta say that looks like a good candidate for that noise. So there's a few electrolytic capacitors here which are potentially a problem in a radio of this age. It's possibly it. I think the strategy will be we'll just change those out, and we'll have to order them. We don't have them in stock, so we'll order those, replace them, see if that gets rid of that noise. Before we obviously do that, we'll have a look at these relays and see if we can give them a bit of a clean, and potentially have a look at the transmit issue. So the next step now is to just have a look at the relays, see if we can clean the oxide off the contacts. Okay, that's quite a nice arrangement. The power amp actually pivots back out of the way, and what looks like, if I get that right, I can actually lift it right out. You're aware that it's connected to everything. Remove the coax, pivots back a bit further. Just a little bit of restricted movement there. Now, there we go. Okay, we're looking at the back of the radio here. The power amp is tilted away, the radio is propped up on a plastic block. What we're looking at here is the filter board. These are the relays that switch in and out the various filter configurations. It is likely that the contacts are oxidized, and that's the reason for the receiver deterioration. So you can see that if a relay was oxidized, you'd actually lose a band. So a frequency, say from 4 megs to 8 megs may be very desensitized, and it would be simply that the relay that covers that filter is the problem. Alright, we're going to try and get the covers off those, have a look and see how easy they are to clean, and we'll do that. It will probably be just a bit of contact cleaner, and if we can get a bit of shiny paper in there and give them a bit of a wipe. Alright, let's press on. Anyway, I was some sense of trying to avoid this, but I think the filter board needs to come out. I'll just see these plugs. Made a bit of a record where everything goes by photographing it. Just grip that there. Two more screws that we didn't see. Quite a nice, solidly built radio. Working our way through the relays. Again, generally there's no signs of deterioration here. It's just a reality of the age of the radio that we just get this thin level oxidization, and because it's a receiver relay, it's got no real voltage or current applied to it that would break through that layer. Clean a piece of paper. Okay, and this is glossy paper. We don't want to leave any fibers that might actually prevent the contact being made. And also, we don't want to use anything like any abrasive material either that would damage the contact. So I'm not sure what the contact's on here, but you know, quite often the relay contacts are a thin layer of silver, or even gold, I guess. No point rubbing that away. Difficult getting into that one. Okay, the filter board's in, all the plugs are back in their receptacles, double checked it, and now I do rotate the power amp back into the chassis, trying not to pinch any of the leads. Okay, anecdotally that seems to have dramatically improved the sensitivity of the receiver. I'm sort of tempted to put an antenna on it now and just see what we can hear. We're going to investigate the annoying tone that we get during startup. Which, there it is. And we poke around, we do get a bit of variation in that tone. Looking for any sort of really giveaways. Because the IC8 5-volt regulator chip here is noticeably getting warm, and it seems to be in the area where this problem is occurring. So I think what we'll do, we'll open the IF board so we can get access to the bottom. We'll see if it's a dry joint. We'll probably replace all the electrolytics, so we'll just turn that down. Okay, so the plan will be that we'll open up the IF board so we can have access to the bottom, check for any dry joints or failed PCB connections, and this 5-volt regulator IC8 and related electrolytics. And if you trace this around, it comes to the display board. We'll replace the electrolytics there that are related to this DC inverter. The DC inverter doesn't appear to be causing the problem, though initially I thought that was a high candidate. It does seem to be around this part of the board. Just put the volume up again. It's still there. Okay, we're just removing the back shield. Quite likely won't need to remove the PCB board. Okay, so this is the panel. This is the IF board here that we want to work on. It's in this metal tray, so we've got to remove it from the tray. Got a series of screws that hold it in place, so that and the whole heatsink will come out ideally in very gently. Just want to lift that out of the tray and leave all the leads intact. Okay, and this is the area we want to look at. This is the 5-volt regulator, and the board, yeah, if you superficially look at it, it looks a little stressed, so we'll proceed with removing the caps and probably the regulator. We'll do this in 2 steps. We'll replace the electrolytic capacitors, fire the radio up, see whether that solved the problem, and then we'll push on to the regulator. If that doesn't solve the problem, then we'll push on and see what else we can find. But at this stage, Okay, the electrolytic capacitors have been replaced, so what we're going to do is put the board back in, turn the radio on, and see if there's any impact. Well, that's pretty dramatic. That has in fact cured the noise, and amazingly the VFO is now stable. So which of those electrolytics was the problem? I'm not sure. It may have been one or both. Potentially it was also a dry joint. It may have been rectified just by reseating the existing ones, but like I say, given the opportunity to replace the electrolytics with new, we've done that. They've also been replaced with electrolytics of the same capacity but with a higher working voltage, so hopefully that for the life of the radio they will never need to be touched again. Okay, this part of the restoration of the Kenwood TS-430S is to replace the failed incandescent backlighting globe with a new bright LED. So it'll be a white LED in this instance, and to get to it I need to be able to tilt the front faceplate forward. To do that I need to take the bottom and top covers off, and there's 2 or 3 screws either side, and that allows you to tilt the radio forward, tilt the faceplate forward, and we'll see what we see from there. Okay, the resistor we're going to try initially is a 1.2K, so a little bit more resistance than I originally proposed, and it is only a 1/4 watt. I'm a little bit concerned that trying to get a 1/2 watt in there is going to be a little bit tight. And on paper, the 1/4 watt looks like it should be sufficient, and we should work. But we're going to wire it all up initially and give it a try and see whether that is sufficient. The diode with the current limiting resistor been soldered into place. This is a temporary arrangement, and the negative's just been twisted on. So we just want to have a look at the brighteners and get a bit of an idea how well this will work. But actually what we're going to do is we just put a little bit of solder on this. And slide the sleeve over here just so we don't make any unnecessary contact. Yeah. Okay. Just tilting that back a bit. So we lined that up correctly. That will be a very effective display. Okay, happy with that. I'll just have a peek at the resistor, and yeah, not warm at all. So that resistor will be completely appropriate. We've got the just to set up with the heat shrink sleeves. Use a bit of the heat from the iron to shrink the tubes. Okay, this is the LED in the mounting bracket. And we'll just screw that back in, and might require a little bit of alignment to get the light down the light tube. Okay, the new LED is positioned. It's sitting in here, mounted in this rubber grommet, which is more or less what it probably should look like. And we'll just power it on. You can see there, and the display looks excellent. So very happy with that. I'm really happy the way a bit of warm soapy water has really rejuvenated the appearance of this radio. Okay, this is the completion of the Kenwood TS-430S restoration and repair. The last activity was to give the front panel and knobs a bit of a wash in warm soapy water, which has really brought them up to almost as new. The bright LED lighting behind the display probably looks better than it has ever looked, much better than the incandescent light. The top and bottom covers have been given a light sand with fine grain wet and dry, and given a spray with grey enamel paint. And while not the original colour, I'm very happy with the way it's come up. It's a very nice looking radio now. We'll just see what it sounds like. This is
Found anybody there, but they were just before I went on leave, or probably before that. They were looking for someone there, I heard anyway. But yeah, so
bit of a rag chew on 80 metres, but the radio is sounding very nice. So that's the completion of this project. Thank you for watching.